I did. Uh, Let me say it again. Those online, can you hear me? Okay, thank you. Can one of you just say something, unmute yourself and say something?
No, yes, I did. Yes.
It's not end. I've allowed your mic. Can you say something? And unmute yourself and just say something so that we can establish if we can hear you from this side. I've allowed the mic of all participants online. Can any one of you unmute and say something?
Good afternoon.
Yes, we can hear you.
Hi. Yes.
All right, thank you.
Hello.
So just keep your mics on mute unless you have been recognized to talk.
Yeah, maybe go.
I think
Okay.
you need to charge it.
Okay, sure.
Okay, so I would do you can just double check, but I don't know how many people are in here. So you can show a lot of things you can show. 2 months. They may
I'm following the measurement. So I'll keep on checking what's happening. At one point in time, I used to play table tennis for the Zimbabwe national team. Then I decided which way, academic sport. Then later on, academic. Yeah. By then, no, for the soccer. Oh, okay. Is it? Oh, okay. Good afternoon, participants. We have to continue from what we did yesterday. I think yesterday we did the EFA. Today we're gonna do the reliability. So let's open our folder, which we created yesterday, EFA and reliability analysis. All of us, I think we have got this folder. EFA and reliability analysis. Let's open that folder. Then once we open this folder, let's open the data file written or labeled reliability analysis participants, right? Let's open that data file. Yeah. Okay, I hope all of us were there, right? We also have a PDF document, written reliability analysis, right? So, okay, let's go through that document. Cronbach's alpha is most commonly used when you want to assess the internal consistency of a questionnaire or survey that is made up of a multiple Likert type scale and items. The example here is based on a fictional study that aims to examine students' motivation to learn. Imagine that as part of this study, we develop a questionnaire that seeks to measure perceived task value as a potential motivator. Specifically, this questionnaire aims to establish students' evaluation of how interesting, how important, and how useful the module they are studying is. So to measure this construct, several Likert type items are added onto the questionnaire. These are adapted from Pinterest and Decruz 1990 motivated strategies for learning questionnaire and include these 8 items, right? All items are responded to on a Likert scale of 1 to 5, and the ones which do have an asterisk, they should be reverse coded, right? So yesterday we spoke about the issue of reverse coding, and I told you that normally we reverse code items which are negatively coded, right? Normally we reverse code items which are negatively coded. So if you read the statement or the item, then you think that item or statement is in a negative way, then you need to reverse code it. For example, number 3 there is written, I don't like the subject matter of this module. So this one is open enough that it's a negative question because of the issue of I don't like. Then also 6 is also a negative question in the sense that it says, I don't think I'll be able to use what I learned in this module in the real world. So which means it's also a negative question. So before performing reliability analysis, if you do have negative questions in your questionnaire or in your data set, you need to reverse code them first before performing reliability analysis, right? So if you do have negative questions in your questionnaire, you need to reverse code them before performing reliability analysis. So you then see that if I open this data file, you then see that question 3 has got an R in front and question 6 has got an R in front, meaning the reverse coding has already been done. Meaning the reverse coding has already been done. That's the reason why there's a small R in front. Otherwise, if there wasn't, then we were supposed to perform reverse coding before performing the reliability analysis, right? So now, let's perform the reliability analysis now. So as usual, we are doing as well as we are writing what? The steps. So we're gonna go analyze we're gonna go analyze, then scale, then reliability analysis. Are we there? Then we click reliability analysis. We take all of our 8 items, we push them to the right. Are we there? Yeah. Analyze, scale, reliability analysis. No, in doing reliability analysis, you can't use ratio or continuous data. Yeah. So I think you see in the notes here, up here, you see Cronbach alpha is most commonly used when you want to assess the internal consistency of a questionnaire or survey that is made up of multiple leakage type scales and items. So you can't use it on continuous data. No. Okay, then let's click statistics. Let's click statistics and let's click all of this. Are we there? And we're writing the steps. Then we click continue. Right? Then we click OK. So what is very important in all this analysis is this value, the Cronbach's alpha. That's the most important thing here. 0.811. That's only the most important value here. Right? Okay. So I think yesterday I said, according to Nunali, the recommended value is 0.7, right? And also some other authors, most of them, they recommend 0.7. 0.7. But sometimes things won't work well in any study. In some studies, things they don't work well. So if you see that your study, you can't meet 0.7, then it means you need to look for some references which kind of goes below maybe around 0.6, some sort. They are there. They are there. It is recommended that you do that. For sometimes 0.7 is very difficult to reach. So in those rainy days, you may need references below 0.7, especially 0.6 of some sort. I'm currently looking for some. I've since saved them for myself when I do my write-ups. But sometimes things they don't work well. And you can't say yeah, there is something for 0.5 as well and 0.6 here. So I've kept these references for myself in terms of rainy days, 0.6 and 0.5 here. So sometimes it happens. Yeah. So I'm just letting you know. Then another thing or another issue of reaching 0.7 is, let's say this one is below 0.7, right? Let's say this value is below 0.7 and you want to rise it up, right? And you want to rise it up. What you do is you go down your results to this table written item total statistics. You go down to this table written item total statistics and you look for the last column, Chromebox alpha if item deleted, Chromebox alpha if item deleted.
I think it is. I'm not sure.
Then you look for the highest value above that one, right? You look for the highest value above that one. So here, if I'm going to delete item 4, my Chromebox alpha is going to improve to 0.832. That's what it means, right? If I'm going to delete item 4 or question 4, my Chromebox alpha is going to improve to, going to rise to 0.832, right? So that's how you can increase your Chromebox alpha. That is, if you do have a situation where the Chromebox alpha is below 0.7, you can go down your results and you check this column to see if you can delete something so that your Chromebox alpha can go up, right? So in our case, there's no need because it's already above 0.7, right? But this is very important so that you know that in cases of rainy days, if you don't find something to delete so that it can, your Chromebox alpha can increase, then you can fall to those references which I've just told you. So it's either of the two, so that you can continue with your write-up. You check for so here our Chromebox alpha is 0.811, right? So if you go down here, you check for the value which is above 0.811. In this case, it is 0.832. So this means that if I'm going to delete item 4, the Chromebox alpha is going to improve to 0.832, right? So in this case, there's no need because our Chromebox alpha is already above 0.7. But if it was below, there was going to be a need because we would want to increase our Chromebox alpha to the recommended threshold value. Are you getting my point? Yes.
Let's say we got the combat data on 0.65. We were going to come in and delete that to 0.6.
Yes. Yeah. Yeah. So that we can increase the Chromebox alpha. But sometimes there's nothing to delete, right? Sometimes you would see that all the values here, they'll be below that one on top. So there'll be nothing to delete. So if you've got nothing to delete, hence you have to fall to those references, right? Mhm.
Does it mean now you're also?
No, you don't. No, just here. You don't delete it from the study. Yeah. Also, I can see there's someone who was asking whether you need to report it or not. Personally, I don't. When I'm doing my write-up, I don't normally talk about deleting. The deleting part, I normally discuss it during the EFA write-up, not on the reliability analysis. Sometimes when you're presenting your results, what you can do is you can, let me check something here. Is it here? I'm checking. Okay, so when you're doing a write-up of Chromebooks Alpha, if you want to show, maybe you can include another column here where you write number of items. You can say number of items here. Then you then see that from your results here, you write 8. So you say number of items, you write 8 here. So if you have deleted something, you can still write 7 here. Then the examiner is the one to see whether the number of items written here, they correspond with the number of items in the question here. Then there's no need of writing that you have deleted, unless if it's an EFA. Understand? Sometimes you don't have to open some can of worms for yourself when you're writing. Okay, colleagues, you need to be very careful when you do your stats write-up. Very, very careful. Each and every time when you're writing your results statistically, you need to write in such a way that whatever statement you write, doesn't bring a difficult question for you to answer. Write in such a way that people, they understand just by reading, then they pass. Not to say, okay, so how, where, what, how, all those questions, right? Don't write in such a way that you open can of worms when you're writing academically. Please, I've experienced a very bad case. I'm not sure how many years ago. Was it 2021, 2019? No, I think 2019, if I still remember. In my office, where one of my clients, a master's who was doing Masters of Commerce in IT here, she fainted in my office. I'm not exaggerating, yes. She came to attend a consultation meeting, and by then we were doing what we call feedback meetings. I was helping her to interpret her results. So she used to write whatever we've discussed. Then she sends that write-up to the supervisor. So that day when she came for more interpretation, she then read her document from the supervisor in front of me. But I didn't notice she was reading, and I was still yet to attend to her. So then I just saw someone falling down from the chair, right? Then it shocked me. Then I had to ask my boss to help me carry her outside of the office. Yeah, then we let her sleep by the lawn. Then later on, she woke up, right? Then my boss left. Then I was left with her. So I had to ask her, why is it that you are fainting? Then she says, the way my supervisor comments when I sent her my write-up is just something else. So when I read it in front of you, all sorts of things, they came up. I'm thinking that with this kind of, all these comments, all these track changes, all this what, am I in a position to finish this degree? Right now, I'm still owing so much at UJ. So lots of things started coming, you see. Then I said, okay, fine. Let's go back. Share me your document so that I also read. Then I read the write-up. Surely it was bad. Each and every time when you read a statement, you're going to ask, but what is this person saying? So many questions comes with the way you are doing the write-up. So don't write bad like this, right? If you don't know how to write, right? If you don't know how to write, let me advise you. A person like me, I'm not a good writer, right? Because I'm a quantitative person. But if you see my write-up, it seems as if I'm a good writer, but I'm not a good writer, right? So let me tell you the trick right now. The trick is copying, right? Copying is a skill. Please take note of this. Copying is a skill. Let me give an example. You see, grade 1 classes, grade 1, grade 2, grade 3 classes, those, you see, if you're getting inside their classrooms, you see there are charts, right? There are charts around the classroom. Math, social science, English, right? The teachers of those youngsters, they create nice charts and they paste them around the class, right? Then they give them a test or an exercise, right? You see one learner getting total, and you see one learner getting 0. And whatever is being asked in that exercise, it is on one of those charts around the class. But someone won't be able to recognize that whatever we are being asked right now is around the surrounding, right? The same applies to you. Let's say you are supposed to write your descriptive statistics. You can't describe the demographics in front of you. Yet there are so many journals on earth which have written about descriptive statistics. Why can't you download 10 or so, put them there, see how they write? Then you copy the language, the style, but putting in your own table which you have in front of you. Done. Why can't you do that? When you're writing about EFA, look for my papers, look for other people's papers. See how they are writing their EFA. Write also. That's the reason why I'm saying copying is a skill. There are things around the world. You see, very simple. As long as you understand the states on the table, now you now need to put them in the nice statistical language. Check how people write and copy. Full stop. Okay, so this is all about Chromebooks Alpha. Is there anyone with a question? Let me check online. Okay, any question? Yes. It is confirming that the internal consistency of your question here is good enough. Yeah. So your question here, being distributed in another environment, in another area, it means you are likely to get the same results. Yeah. Okay. Online, talk to me. Okay, let me check. How much now? 77 per 3. Okay. Yeah, it's going good. Yes. The Chromebook software. Yes. Yes. Yeah. You still have to do that. Then on your factor analysis, you do the confirmatory one. Yeah, enable their mic. They can speak online. Okay. Disable mic. I think they're allowed.
Now we are allowed, but before we're not.
Okay.
Yes. So my question is, yesterday you said that if you do a pilot before and then you measure the Cronbach's alpha, then it will tell you whether you can proceed, which means that here in this was this particular sample that we're looking at of a pilot or of the main study. And so you said that in the write-up, either show that you removed some questions, but if it's a pilot and you're going to edit it anyway, so that you can get a better Cronbach's alpha, then I don't see the problem regarding the write-up. I hope my question is clear.
Your question is very clear. Let me answer by an example. Okay, let me close what I had done earlier. Then, so that I can be able to answer you. Okay, so this is one of the studies which I've been doing with some other. Okay, so maybe you'd like to see the question here as well. This one. So this was during pilot study. There is this construct career path and motivation. It has got 6 items, right? So she collected her data. As you can see, this was based on a pilot study, and she has got 30, right? So now the first construct is career path and motivation, 1 to 6. So I'm going to quickly analyze this so that you see what I'm talking about, what we do during pilot study. So we do exactly what we've just done, right? And you see, then I do this. Can you see this Cronbach's alpha? How much is it? 0.352. Can you see? Now, what I've told you that you then go down here to check if there's something above which you can use to rise that Cronbach's alpha, right? So here, if I remove item 2, it will rise to what? To 0.491, right? Can you see that? So,
Yes.
So I'll close here, right? I'll close here. I'll go back again here. Reliability analysis. Item what? I take item 2, I put him back here. Then I say, okay. Can you see that it's now improved to 0.491? Can you see that? But what you need, this is during pilot study. So already what you need to know is item 2 is a suspect in my question here. So before I go to the main study, I have to revise item 2 or remove it and replace it with another item. That's how you do when you are doing questionnaire development during pilot study. then 0.491 is not good enough again, right? So you go down and check whether is there something which is better than 0.491. Yes, there is 0.569 on what? On item 6. Then you close again, right? Then you take him here, you put him here, you are left like this. Then it rises to 0.569. So already item 2, item 6, they are suspects in my question here, right? You go down again. There's another one, 3. It will rise to what? 0.671. So there's a need. So you go again, go back, scale, reliability, 3, go back like this, 0.671. So item 2, item 3, item 6, they are suspects, right? You go down, is there something again to improve? Right? There isn't. Because now all of these values, they are below 0.671, isn't it? So then we end there. So in my feedback to the researcher, I will then tell the researcher that before you go to the field, revise your question here. On career path and motivation, item 2, item 3, item 6, there are suspects. Can you please edit them or please remove them? That's how we develop the question here. Understood?
Yes.
We're now online.
Yes,
Have you understood?
but
Yes, we
I
hear
haven't-
you.
But now the question is, when you're writing up for the main study, like when you fix it up now, and you do the main study, do you now have to talk about the pilot and these items that you had to remove or the changes you had to make, or can you now work with the main study that is improved?
Obviously, you are going to work with the main study that is improved. Then, regarding pilot study results, it depends with your supervisor. Some supervisors, they don't need to see pilot study results. Some supervisors, they do. If you are going to present your pilot study results, you present them at the back of chapter 3. Because normally chapter 3 is your methodology, isn't it? So you present them at the back of your chapter 3 if you are to present them in your study. But some supervisors, they don't care about pilot study results. So you may not present them. It depends with the supervisor.
Okay,
Understand?
thank you. Yes, thank you.
Okay, sharp. Yes.
So sir, if I got you right, it means that is it advisable to carry out a pilot study, whether a supervisor asks for it or not? And that means you must carry out a reliability analysis for your pilot study before going ahead with your research.
Okay, when it comes to the pilot study, I'm sorry, the supervisor doesn't have a much choice in that. We have to do pilot study.
Whether you request for it or not.
Yes. They I'm the one ruling, right? If you are coming for consultants, then it's me now who is going to power over the supervisor. It has to be done most. Supervisor doesn't have choice. Yeah. But in terms of writing up the results of the pilot study, then yes, he can choose whether to be included in chapter 3 or not. But myself, I've done, because I'm also protecting you for the main study so that we get better results in the main study. That's the results why we need to do pilot study.
Was it was carry a pilot study and was conduct reliability analysis for it.
It is.
Yeah. Because imagine now after you've collected data, everything, then you find that your instrument that you use
0.3.
is not correct.
Yeah.
What are you gonna do? Are you gonna go back again to collect the data? So that's the purpose of the pilot study. It's for you more than even for the supervisor himself. Yeah. Because you don't have to there are some people who come, maybe they come to consult with the results that are not working. Then they tell you that can you assist me? But how do I assist?
How do I assist?
The only thing I can tell you is go and collect data, collect your tool and go to the field again.
Yeah. Yeah.
That you needed. If I may ask, there is certain sample size pilot study.
30.
30.
Yeah. Okay, remember I told you in terms of sample size. I told you during questionnaire design that if you want to do a quantitative analysis, right, before you even put a pen on your proposal, check where you're going to get the data. For example, my problems with many researchers comes when you start to do pilot study. You now tell a student now that go and collect 30 participants for pilot. Then he's going to say, 30 for pilot? 30? That's all the people in my company who can answer your question here. 30. Then you say, so why were we starting quantitative analysis if everything which we have is that? Go back to qualitative. You see, but sometimes, for example, I'm sorry to say this, but if I can show you this study, it's pathetic. This one, let me show you. Can you see all of this? All of this, they're supposed to be revised. You saw all those constructs, they're supposed to be revised. So almost the whole question here needs to be revised. So which means you're supposed to go and collect 30 more again. You see, so 30 plus 30, how much? 60. How big is your population when 60 is now going only to pilot? Right? So it's very, very important that before putting a pen, right, onto a proposal, I told you the very first day when I came here that when doing quantitative techniques, before you pen anything, start to look at your population. How many people are available? Doc, yes.
So let's say I do a final start. After you do the assessments, then everything is working well. Can I use those data already as my part of my participant? Do I think need to collect again from the same people, or I can now use those data in the analysis of start?
If they have worked well, you can use them. So which means you're starting from 31 going onwards. But if they didn't work very well, you start afresh from 1. Because if they've worked well, there's no need of changing anything, right? So you are now continuing. But if you've edited your questionnaire again to capture for those changes which you've done, then you need to start from 1 again. Yes? Yeah.
Yesterday when we were doing construction,
Validity.
today we are doing analysis.
Mm.
We are trying to check the question. We are trying to check on the constant value. We are trying to check if the items under the constant are present constant. Now today we are trying to check the reliability of the question. Why do you need data for that? And we check the question even before it's.
Okay, remember there are other kind of validity, right? For example, there's first validity, there's content validity. Those are kind of validity which you can check based on expertise of professional people, right? They are there, those kind of validity. That's the reason the one which we were doing yesterday is called construct validity. That one is data. There is first validity, go and do it. There is content validity, go and do it. But there is construct validity. You need data for that.
But we don't check through the questions.
Yeah, but sometimes on a facial point of view, it's more subjective, right? It's more subjective. Yes, you are a professional in your field. You think this item is good enough, right? But practically, it may not be good enough. Because what happens with the reliability, right? What happens with the reliability is there is this thing. Can you please read this? To help determine whether a collection of items consistently measures the same characteristic, all of them together, are they talking to the same construct? So there may be 1 or 2 which you think they are measuring the same construct, and they are not. So from your content validity, you are fine. From your face validity, you are fine. But statistically, using SPSS or using a statistical test. It's not like that.
Those tests have already been done. Therefore, you have a closer idea as to whether it's too much. I think.
Yeah, it goes back to questionnaire design. So that's the reason when we were discussing about questionnaire design, we said, start to look into the body of literature to check whether, do you have anything around, like some constructs which have been measured or pre-existing questionnaires, right? Then you see whether, if they are there, make use of them. If they are not, then yes, there's need of creating new statements in construct from literature. But it's very important that you first check whatever is existing, so that even when we measure reliability on those, at least they've been tested before. They won't give us these 0.3s, right? When they fail closer to 0.7, not to 0.3, right? Yeah. Yes? Question? Okay. Then online, there's a question which I've seen here. Whereby someone is asked, whereby someone is asking whether can we use Conbrax alpha on the yes no questions? No, we can't. Thank you. You can ask.
Yes, thanks, Prof, and all stakeholders present in this platform. My question is that it's relating to the Cronbach alpha. Say your study is measuring 3 constructs, and then ideally each construct has got something like 5 or 6 questions that are associated to it. So would you run this Cronbach alpha for all 3 constructs separately, or you will combine the results and actually have one Cronbach alpha? That's my first question, Prof.
Okay. Normally Cronbach alpha is run per each construct, right? Unless
Seconded, Prof.
Unless those 3 constructs which you are talking about, right?
Yes.
If they do you understand the concept of second order constructs and first order constructs? Do you understand that concept?
No, Prof, I don't.
Yeah, unless those 3 constructs, right, are first order constructs which are measuring a second order construct, then you can run all of them in one to get one Cronbach alpha. Yeah. Okay, let me look for an example from my past studies. I'll quickly look for an example if I can find one. Yeah. Hey, you guys, your questions. Hi. You want to make my hair more gray, right?
Apologies, Prof. It's just that we still expected to, present the way you're teaching us now. So this research that I'm pursuing, I think it's measuring 3 constructs. So it means that I'll have to run the 3 Cronbach alpha for each construct. Yeah. And then maybe hopefully get the 0.7 for all 3 constructs. Yes.
Okay, I'm trying to check something which might assist us. Because I remember one, there's this other student who I think we also ended up publishing again the work. She was measuring burnout, right? let me see. She was measuring a construct called burnout. Burnout is a second order construct, which is measured by 3 first order constructs. Like, for example, like this. So you see, so
Yes.
so burnout is measured by, okay, let me try to look for the question here. If I can find it. Okay, yes. So burnout is measured by three constructs.
Yes.
One of them is called emotional exhaustion, right? So another one is called depersonalization. Another one is called reduced personal accomplishment, right? So, so at the end of the day, burnout is a second order construct. Are you getting my point? Being measured
Yes.
by 3 first order constructs called emotional exhaustion, depersonalization, and reduced personal accomplishment. So all this they measure burnout, but each one of them, they have got some individual statements measuring it. Can you see?
Yes.
So we can have 1 Cronbach's alpha, right, for all the 3.
Yes.
As well as we can have 3 separate Cronbach's alpha for each first order construct. Are you understanding this?
Yes.
Yes. So
which one is more preferred to have each Cronbach alpha for each construct, so that if the other one it's lesser than 0.7, you can now do what we were doing or we were practicing earlier, where you try to remove some of these questions that are affecting it?
No, that is not the reason why you need to consider that. The reason why you need to consider whether to use the second order factor as it is or to use separate first order constructs is through your objectives. If, let's say, in my objective, I'm using burnout as it is, not separated into 3, right? I'm just taking burnout as it is, then you use that 1 Cronbach's alpha. But if you think you'd want to use burnout in different scenarios whereby use the three first order constructs, then you need to measure it separately like that. So it depends with your objectives. You don't just do things in statistics without a reason. No. Each and everything we should do in statistics should have a reason. Understand?
Yes, Prof. So when you say objectives, maybe can you run us past one example? When you say it depends on the objectives.
Yeah, you know, these kind of questions we don't finish now.
Apologies, Prof.
We don't finish what we okay, for example, can you see that apart from burnout, we've got another construct here, depression?
Yes.
Right? Yes. Let's say we want to measure the relationship between burnout and depression, right? So our objective is to determine whether there is a relationship between burnout and depression. That's our objective, right? So if you want to measure the relationship between burnout and depression using burnout as it is, without separating it into 3 subconstructs as it is, right? You are going to say, what is the relationship between burnout and depression? Then you go like that. But the moment when you say, what is the relationship between burnout measured by emotional exertion, reduced accomplishment, and this and this and this, which means you are now measuring burnout using these 3 subconstructs. So which means your analysis should stand whereby those 3 will you're gonna measure them, the relationship against depression. So which means you are going to have 4 constructs in your correlation analysis instead of 2. Understand?
Yes.
Yes.
Resulting to 4 Cronbach alphas or 3.
If it's Cronbach's alphas, then you resulting in 4. 3 for burnout and 1 for depression.
Seconded, Prof. Thanks.
Okay, sharp.
This looks So but now, I want to explain again what you just explained. I think it's about three pullback alpha and pullback alpha and all sorts like that.
So we are saying sometimes you do have a construct, which is big. We call it a second order construct, right? Which will be measured by other subconstructs. And we normally call them first order constructs. Yes. So now it depends with the way you are going to play around with such. So for example, let's say you are using from the validation itself, like this example of burnout. And you then see that all these examples which I'm giving you, they've already using pre-existing questionnaires, right? That's the reason why you see here, we are checking whether emotional exhaustion, depersonalization, reduced personal accomplishment, and we are combining them like this. Whether these three are measuring the second order construct, right? And we are using CFA. This is CFA. Yesterday we didn't do CFA. This is how CFA looks. Yeah. This is how CFA looks. So we are checking whether all these three are they measuring burnout. Yeah, like that.
So what does that got to do with pullback alpha 1, 3, 4?
So now when you're measuring Cronbach's alpha, we are saying you can measure Cronbach's alpha, taking all the items measuring those three first order constructs, right? So that you can have one Cronbach's alpha. Or you can measure Cronbach's alpha separately, one for emotional exhaustion, one for depersonalization, one for reduced personal accomplishment. Yeah. Single-handedly like that. Okay.
Which one is better?
It depends with the objectives. It depends with the objectives. What is it which you have to achieve? What is this saying? But I thought that with the yes or no case, that Cronbach's offer treat them as special cases of ordinance. That is using the KR20 formula, which is valid for binary if they measure the same underlying construct. Okay. Okay, that's the reason why I'm saying you don't use Cronbach's offer for what can I say, for the no yes questions. So if you are saying or you are suggesting to use KR20 formula is not Cronbach's alpha. Okay, any questions online? Hello? Okay,
Yes,
if
Doc.
there are no more, yes.
Yes, Doc. I think you've explained comprehensively and on all this, but one big problem is that I think a lot of frustration for a lot of students is most of the supervisors has no idea of all these things. So by the time you even do your stuff, they could even say you're wrong. Like I did in my master's, I did 700 questionnaire. And I did a pilot study, I still did 700 questionnaire. If not for the fact I fought, I wouldn't have even graduated. But everything you explain are things that I did, and still it wasn't good enough for the supervisor. Supervisor was still saying, this is not the way it's done. So what does one do when someone hits such a roadblock?
Okay, look, disagreements with supervisors in terms of some certain situations academically, they do happen. It's often. Personally, I'm one of those people who experienced it during my PhD, whereby my supervisor was interpreting regression analysis wrong, right? I experienced it myself. So sometimes the only way to work around it is pull some literature which supports your argument, send it to him or her, or ask him to, what can I say? Let's say, for example, you can talk to him to say, okay, can we take our argument to one of the consultants at StatCon? Because, for example, here at UJ, StatCon, us, we work with statistics. So then you can kindly ask him to engage us. Then we can intervene, something like that. So that's the only way to go around it. So that maybe a professional person can intervene like myself, or literature can intervene. Otherwise, those kind of arguments, they do happen. Myself, I've experienced it. So I don't dispute what you're saying. Understand?
Thank you, Doc.
Okay, sharp. Okay, also that's the reason why when we do such workshops like this, we also invite those supervisors as well, so that they can also get to know this as well. You can't use Cronbach's alpha on multiple choices. Okay, sure. Do we still have any burning question on what we have covered so far before we move on? Okay, no, sharp. So, can we please have our outputs is reliability analysis. We are saving our output. What was the name of that construct? Perceived task value. Then you say perceived task value. So can you please label your label and save your output on reliability analysis? Huh? No, that one you are just saving it as it is into your folder. So I think I told you that on Cronbach's alpha, what we are mainly checking there is that value, Cronbach's alpha value. Nothing much. So as the result, Cronbach alpha results can be linked with EFA results so that you avoid having many tables. Like if you took your time to look at that article which I shared with you yesterday, which I wrote, you can see that the EFA results, they are linked with the reliability results in one table. Okay, once you have saved your output files, let's move on. So we need to close everything about reliability analysis. Then I hope you now have a new folder which you have opened today, based on what you have been what you have received today from the other DC people. Then the new folder should be called comparing of groups techniques. I hope you now have a new folder written comparing of groups techniques. Let's open that folder. Let's open that folder, comparing of group techniques. Then once we open it, there are two files which I want you to open. Statistical techniques for comparing of groups, salary for participants, right? Something like this. Then also the data file, salary, SPSS data, right? Also open that one. Those two files are the ones which we are going to use mainly throughout the whole session until 4 o'clock. So this is the data file. Yeah, this. So I hope those two files are open. Whilst I'm just checking where we are. 127.5. Huh? They should lose most. Those we should draw most. It must be 1-1 today. No, I don't have. Yeah. Okay. Are we there? Are we there? Okay. Good. Let's move on. Okay, so let's understand this data. The data for this example consists of salary information and related biographical information of employees at a certain company. Measures or variables included in this example are the following. We've got gender, we've got beginning salary, which we shall call SALBEG. Then we've got job seniority, period of service over time, then age of employee, current salary, which we shall call SAL now, educational level, which we shall call ED level, work experience, work, employment category, job cut, minority classification, minority, sex and race classification, sex, race. So these are the variables which appear in our data set. As you can see, these are the variables here, right? As described. Now, as we go down, what we are going to be doing today is more of what we call hypothesis testing or confirmatory data analysis using the p-value approach, right? Hypothesis testing or confirmatory data analysis using the p-value approach. The reason why we are saying using the p-value approach, it is because there are also two other approaches which you can use for hypothesis testing besides the p-value approach, right? Is there someone who can tell me which ones? Huh? The t-value, yes, yes. So there are three, yes. So there are three, the t-value is one of them. Another one, p-value now, t-value. Another one. No, we are saying how to reject or fail to reject. So if you are using the t-value, we are using this thing that 1.96. If your value is above 1.96, then it's statistically significant. If it's below, it's not statistically significant. So p-value, if it's below 0.05, it's statistically significant. If it's above, it's not. So what else can you use to reject or fail to reject? Let me check on the chart. I didn't get the document being discussed. Where were you? I'm not sure. How can I help? Okay, so other two ways of carrying out hypothesis testing besides the p-value and the t-value. Okay, you can use what we call the confidence intervals. You can use the confidence intervals. And you can also use what we call the credible intervals. So you can use the confidence intervals as well as also the credible intervals. So the credible intervals, you get them from the Bayesian approach. The credible intervals, you get them from the Bayesian approach. Then the t-values, the p-value, the confidence intervals, you get them from the frequentist approach. So there are two worlds of statistics. the frequentist approach and the Bayesian approach. So the frequentist. So from the frequentist approach, you get the T values, you get the P values, you get the confidence intervals, right? Then the credible intervals, you get them from the Bayesian approach, right? Frequentist approach is written there. Frequentist. So what we're gonna do from today until the whole of the sessions remaining, we shall be doing hypothesis testing. Everything which we shall be doing shall be hypothesis testing using the p-value approach. Everything which you shall be doing is hypothesis testing using the p-value approach. So that's the reason why yesterday when you were asking, I told you that hypothesis testing is very broad. Also, inferential statistics is also what? Very broad as well, right? So now we need to understand how to do hypothesis testing. Reject or fail to reject. Very, 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 very important. The moment when you fail to understand this concept, then you are gone. Everything on inferential statistics won't make sense because you won't be able to reject or fail to reject, right? So we are saying hypothesis testing is an act in statistics of testing an assumption regarding a population parameter, right? A statistical hypothesis test is a method of statistical inference. A statistical hypothesis is a method of statistical inference. That's why I told you yesterday that hypothesis testing falls under what? Inferential statistics, right? Hypothesis testing falls under what? Inferential statistics. So in research, it is very wrong to use descriptive statistics to conclude your results or to infer your results to the general population using descriptive statistics. Is very wrong, right? Also, the way you interpret your descriptive statistics must not be used in such a way that you are generalizing those results to the general population. Never. That's the reason why we do have inferential statistics. Because inferential statistics, the results from the inferential statistics are the ones which we use to generalize those results to the whole population, not results from descriptive statistics. You need to get that correctly. Understand? Very, very, very important information which you need to take care of. That's the reason sometimes your supervisors will cancel or will nullify your results or the way you're writing, because you are using custom tables, you are using frequencies to generalize your results to the whole population. That's wrong. Those strongly agree, disagree. Whatever you get there to say, so many people agreeing, then you say, so it applies to the whole of South Africa because these ones are agreeing. No. Understand? Okay, now, after understanding the importance of inferential statistics, right? That's the reason why for any study or for any research, it is very important to do some inferential statistics Because whatever you get, if it's a report, if it's a dissertation, if it's a thesis, whatever findings you get, you can be able to apply them to the whole population, right? That's the reason why it's important to include financial statistics in any study, right? And that's the reason why they also say at master's and PhD level, it's not sufficient that you just end with what? With the descriptive statistics, right? You are not doing research just to pass. You are doing research to teach or other people as well, right? Inferential, yes. So steps in hypothesis testing, first and foremost, you must be able to state the now, which is H0 hypothesis, and the alternative hypothesis, which is H1 or HA, right? So from your proposal or from your chapter 1, right? Either the proposal or chapter 1, you do have your aim up there, right? You do have your research questions below. Then you do have your research objectives, right? Then you do have your hypothesis or statistical hypothesis, right? It is not every objective which deserves a statistical hypothesis. Understand? It's not every objective which deserves a statistical hypothesis. Descriptive kind of objectives, they don't deserve a statistical hypothesis. Please. So you see some people, they do have a descriptive kind of objective. And they're coming up with a hypothesis for that. No, you can't. For example, we are saying what is the prevalence of people who suffered from coronavirus at UJ in 2020. That is descriptive, that one. Because you are just checking how many males and females who suffered from coronavirus during that period of time which you are talking about. And that you can't come up with a statistical hypothesis for that. But you see some people coming up with a statistical hypothesis for that. What kind of a statistical test are you motivating for such an objective? None. Just frequencies. So it's very, very important that you link your statistical hypothesis with an objective which is inferential in nature. Yes. The moment when you're comparing between males and females on a continuous variable, when you are comparing males and females on a certain continuous variable, then it becomes inferential. So once you formulate your now and alternative hypothesis, so normally the now hypothesis starts, then followed by the alternative hypothesis. And we normally call the now hypothesis an hypothesis of no difference. A now hypothesis can also be called an hypothesis of what? Of no difference. You are learning, huh? Yeah. Now hypothesis can be called an hypothesis of no difference. Now hypothesis. Now. Yes. Yeah. As we go further, you shall see the way we are formulating all our now hypotheses. Then I need you to relate to that statement. Yeah. Yes. You're asking. You can answer.
The physician spends more time average weight patients than with obese, right? So we're trying to see if there's a difference in the time spent with more patients. But then in the null hypothesis, we're saying that there's no difference at all. That answers it.
Okay. To just
Relationship.
okay. Okay. All of you, you are missing one thing. Relationship difference. Statistically significant difference. Statistically significant relationship. So those two terms are important. Statistically significant. Very, very important. Difference, relationship, association, whatever. But it's statistically significant. That thing is very important. Okay, now let's continue. So after formulating your now hypothesis on the alternative hypothesis, then you need to determine the level of significance, which is your alpha. So normally we do have three types of alphas. We do have the 0.1, we do have the 0.05, and we do have the 0.01. Although these days, with these statistical packages which we have further 0.00, but we've got three main types: the 0.1, the 0.05, and the 0.01. Right? However, the 0.05 is the most commonly used one. The 0.05 is the most commonly used one. Right? Then the history of this level of significance, emanated from the time when a certain company was manufacturing light bulbs. So they started by testing their light bulbs using the 0.1 level of significance. And they then experienced so many complaints, people complaining about their light bulbs being faulty, right? Being faulty. So they adjusted to 0.01, which is very stricter, right? Which is like 1%. Then they found themselves throwing many light bulbs in the bin, but they were not conforming to the standard. So they were now running a loss. So then they had to come back and say, okay, in between 0.05. Then until now, we are still using 0.005. So that's the history behind the issue of level of significance. So we normally use 0.05, 5% margin of error, right? So now you have your level of significance, yes? Okay, we are going there. Yeah. So after figure out that we are now using 0.05, right? You now have to compute your p-value. So p-value means probability what? Value. And lucky enough, there are now statistical software which can now calculate the p-values for us, like SPSS, right? Some of us, the time when we did our BSc mathematics, we used to calculate these p-values using a calculator. Those sharp scientific calculators, we used to calculate this, manually. Yeah, using those complicated formulas. Those were the times when we did our mathematics. Yeah, it was not easy. It was not easy. So, like enough these days, SPSS, Starter, SAS, thanks to the calculator for us, right? Now, you now have your p-value, you now have your level of significance. So you need to compare the p-value with the alpha level using the following decision criteria, right? So which means when you get your results, your p-value, what you do is you write your p-value to your left. You write your alpha to your right, right? Then you write, please get what I'm saying. It seems as if I'm joking. Now, if I'm going to ask you in about 10 minutes to come to say, do we reject or fail to reject? Then you look at me without giving me an answer. Yet I'm giving you a formula right now for how to go about it. Once we get the p-value, you write your p-value to the what? To the left, right? You write your level of significance to the what? To the right. Then you use your greater or your less than signs. Then you then apply your greater or less than signs, right? So now the decision criteria is the following. If the p-value to your left is less than or equal to, that's what we are asking. If the p-value is less than or equal to 0.05, which is your level of significance, right? The null hypothesis is what? Is rejected in favor of the alternative hypothesis, right? Then if the p-value to the left is greater, right, than your level of significance, right, you fail to reject the null hypothesis, right? No, we don't accept, and we don't want to hear that word to say accept. We don't use that in statistics. We fail to reject. Yeah, we fail to reject. Yes? Yeah?
We just rejected in the first statement. P-value less than margin of error. We said the non-fixed is rejected,
Yeah.
but in the other one, we don't use accepted.
Yeah, we don't use the word accept. We fail to reject.
Okay, that's the right word.
Yeah. Please get the correct terminology. Right? Yeah. Okay, it seems as if there's a question here. ZS, talk to me. What's up? Yeah? I'm moving if you don't want to talk. Yeah? Hello, Mike. Okay. Talk to me.
Yes, thanks, Prof. Man. I would request that you just recite what you said about the p-value on the right being greater than the level of significance. The p-value on the left being greater than the level of significance on the right. You were saying if the p-value is
You fail to
greater than...
reject. You fail to reject the null hypothesis.
So you fail if the p-value is greater than the level of significance.
You fail to reject the null hypothesis.
What does that mean when you say you fail to reject?
You shall see by an example. We are moving there. Be patient.
And then if it's the other way around, if the p-value is lower than the level of significance.
You reject the null hypothesis.
Oh, okay. No, thanks, bro.
Okay, sharp. Okay, let's move on. Now we need to move on to the independent sample t-test. An independent sample t-test is used to compare the mean score on some continuous variable for different groups of participants. Okay, so before I move on with this, remember when I spoke about the issue of normality last time, we said normally the issue of normality is important because we'd want to check whether we do what we call parametric tests or non-parametric tests, isn't it? So you have to know that independent sample t-test is a parametric test, right? Independent sample t-test is a parametric test. Okay, so we only use it. It's very, very important. There are conditions here which you need to know, right? There are conditions here which you need to know. These are the conditions, right? When you are running a t-test, these are the conditions. You need one categorical variable with two groups or two levels, right? You need one categorical variable with two groups or two levels, right? For example, gender, males and females, done. That's independent t-test, right? And I hope you still remember what is a categorical variable, right? Then you also need one continuous variable. And I hope you still remember what a continuous variable is. So you are comparing these two groups against one continuous variable, right? That's what you are doing on independent t-test. So for you to be able to use this kind of test, make sure in your research you do have an objective which can meet this kind of test. Don't just use a statistical test for the sake of using them because they exist in the world of statistics. No. Make sure you do have an objective which you are going to claim that to meet A, B, C, D, an independent t-test was utilized, right? Then you are going to go deep with it. So in this case, we wish to compare the current salary of males and females, whether males earn better salaries than what? Than females, or it is the other way around. That's what we want to check. Because we say we do have the data for this company, right? Whereby we've got the current salary, we've got the salary which they begin earning when they started working with that company, and we've got their biographical details, right? So we now want to use the information of the biographical details against their salary. So these are the steps. So today there's no writing of steps. You are lucky, right? So the steps are given for you here. So what we're going to do right now is just to analyze, right? So let's go to our data file. Let's go to our data file. Okay, let's go to our data file. So we're gonna go analyze. Oh yes, yeah, it says of the two. You can develop it now to say there is no statistically significant difference in current salary between males and females. A significant difference, yeah, in current salary between males and females. Huh? That's what you are testing, yeah. Now you go analyze, then you go compare means and proportions. Then you go compare means and proportions. Analyze, compare means and proportions. Then you go independent samples t-test. Then you go independent samples t-test. Are we there? Then you click independent sample t-test. Right? Then under test variable, you insert the continuous variable which you want to test against. Under test variable, you insert the what? The continuous variable, which is the current salary, which is SAO now, right? Then you put him here. Are we there? Yeah, you put him under test variable. Are you there? Then under the grouping variable, you insert the what? The categorical variable, right? Then in this case, it's what? Gender. Then you put him here, right? Then immediately when you put your gender there, SPSS will ask 2 question marks one time, right? What does SPSS want? To divide the groups. So when dividing the groups, what do you do? When dividing the groups, what do you do? So you click divide groups. Yes. What do you do? You have to insert the codes. Yes, you have to insert the codes. I do agree. But our codes, are they 1 and 2? Are they 1 and 2? What are our codes?
Go back to male and female.
Prof, please advise us which variables are we taking to the right.
Under
now we've
test
got-
variable,
Yes.
variable, you put the continuous variable, which is salary now.
That will be Salpec, yes.
SAO now. No, not
Or
SAO.
SAL now.
SAO now. Yes.
Oh, okay.
Then under the grouping variable, you put the gender. Okay. So now, don't just take for granted that a male female is coded as 1 and 2 every time. Please. Don't take that for granted. Especially if you are not the one who created that particular data set. Right? Don't just take things for granted. Go to your variable view. Right? Go to your variable view. So you cancel here and you go to your variable view. Right? Now I'm in my variable view. Gender. Then you go to values. Then you check 0 males, 1 females. So you were wrong when you were saying 1 and 2. And you were correct. Right? So don't just take things for granted. Right? So can you see where we are getting the codes? Yes. Go to your variable view. Then you go intersection of gender and values where they meet. You click. Are we there? Mm-hmm. Whilst you are checking that, let me check my. Oh, you won. Oh, wonderful. Sure. At least now it's 1-1.
Yeah.
Yeah, better. Okay, then we go back here. Define groups. Then you substitute 0. You didn't get it? I gave you time, Moose. Are we there? Are we there? Okay, then we click continue. Then, huh? Mail, yeah. So you just put your 01 here. 01 here. Right? 01. Are you there? Yeah, then you click continue. Then you make sure that estimate effect size is ticked. Estimate effect size is ticked, right? Then you click OK. So these are our results. These are our results, right? Okay. So now, if you see your results, there are two tests there in that table, right? There are two tests there in that table. The first one being what we call the Levin test for equality of variances, and the one called the t-test for equality of means. If you go back to this table, you see there's Levin test for equality of variances here, and there's t-test for equality of means here. So there are two tests in that table. So you must be able to recognize that, right? So when you are interpreting independent t-tests, they are steps, right? They are steps in interpreting t-tests. You don't just one time interpret t-tests. No, they are steps. So the first one is step one, whereby you need to look at the Levin test for equality of variances. So which means you are only looking at the first three columns only. 1, 2, 3, done. First look at those first three columns and deal with them only. That's the first step. First deal with the first three columns, right? 4 columns, right? If we're going to include sound now, if we're to include sound now, it means 1, 2, 3, 4. Yeah. First 4 columns, you deal with them. That's our step one. So firstly, we have to test if the variances are equal or the same for both groups. In order to test if the variances are equal, we need to identify the null hypothesis in the alternative hypothesis. H0 will be the variances are equal. H1 will be the variances are not equal, right? So now this is our p-value. I think I told you yesterday that wherever you see a sig in SPSS, that's your what? That's your significance value or your p-value, right? Good. So now, can you please tell me whether you reject or you fail to reject? Now. And what we conclude saying? If we reject, what we conclude? Eh? Where is the significant difference coming from? Eh? Where is your significant difference coming from? Where is your significant difference coming from? What did we say in terms of our null hypothesis and alternative hypothesis? You're not listening. You were not listening carefully. What is our null hypothesis and our alternative hypothesis respectively? What is our null hypothesis and alternative hypothesis? No, we are not listening. What is our null hypothesis? We said we have got some steps when dealing with t-tests. The first step is to what? What is our first step? Oh, finish. I'm going.
I think we write down the p-value on the left, and we write the significance to the right.
Ladies and gentlemen, if you can't give me this answer, I'm going. Serious. There's no way I can be here for nothing. I'm going.
So if I remember well, we said in our not hypothesis, there is significant statistical difference between male.
No. Another one.
We write the P value
My
to the
brother, I'm
left
leaving.
and the
I'm leaving. I'm
significance
talking
to the
alone here.
right.
No, you're not listening.
Guys,
I'm wasting my time here. Let me go. Tebacho. No, I need to leave.
which one is that?
Okay, Tebacho, try.
Good day, colleagues. Prof, are you
Yes.
asking what a null hypothesis is and alternate hypothesis is?
Okay, I'm asking the first step, which we said we are doing right now, and is now hypothesis and alternative hypothesis. What did we say? Okay, thank you, Tamlin Ngos. If it was not this person, I was leaving. Serious. I was leaving. Serious. No, I can't speak alone right now. I've got a lot of things to do in the office, and you're not paying attention. I know. I'm not joking here. First, we have to test the quality of the variances. I said so. I said we've got steps when you dealing. And remember, I told you that we are dealing with the first 4 columns first, where we are dealing with the equality of variances first. And you have to formulate the now and the alternative hypothesis for it. That's what I've said. And you're not paying attention. I can't send here for nothing, guys. I've got a lot of things to do in the office. So I can simply say this is our last workshop. Serious. My boss is even here to say, why are you giving them all those workshops? Yet there's a lot of work here to be done. Lots of designs, lots of analysis. You're not paying attention, which I have to do. Okay, so you deal with the first 4 columns, right? Leaving test of equality of variances. And you have to formulate the now and the alternative hypothesis for it. So we are saying the H0, the variances are equal. H1, the variances are not equal. Then we go back to our results here. What do we do now? Do we reject or we fail to reject? What do we do? We reject. And what do we conclude to say? We fail to reject. Remember, I told you, right? Write your level of significance there. Put your grade and give me a correct answer. Don't just guess. What are we doing right now? In this case, what are we doing? We reject. What good to say? And say what?
The variances are not equal. You remember when you are reporting, you report in terms of the hypothesis that you have stated.
Exactly.
Remember to say there is no significant difference. That's a general statement without you having specified a specific hypothesis that relates to your study that they are doing. To the variables that they are testing, maybe it's
Now we do have these 2 hypotheses there in black and white, and you are saying no difference. But we are saying these are the 2 hypotheses which you are dealing with right now. Where are you getting no difference from? Please listen and listen carefully.
in this case, the variance is equal.
H naught, the variances are not equal. So if you reject H naught, then it means you are saying the variances are not equal. If you accept H naught, then it means you are saying you remember when you accept H naught, you are rejecting H1, meaning you are saying the variances are equal.
Ay, 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 ay. Ay, 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 ay. Okay, so because this p-value is below 0.0, because we are saying it is less than 0.01, right? So if it is less than 0.01, automatically it is less than 0.05, right? Something less than 0.001, right, is less than 0.05 automatically, right? So we reject the null hypothesis, which is saying the variances are equal, right? So the reason, can you please take this and take this carefully? The reason why we have to deal with the quality of variances is because the results of independent t-test are in two ways. From here, from the fifth column going to the right, we do have two results here. The top and the bottom results. Can you see that? So this result which we are getting now will help us to know which row to use when we are now doing independent t-test. Are you getting the point? Are you getting that point? So because we are saying we are rejecting the null hypothesis of equal variances, which means we are going with what? Equal variance is not assumed. So which then means that when we are now moving to the independent simple t-test, we are taking results from what? From the bottom row. Are you getting the essence of it? Yes. Yes. They are not equal. So which means we go with the bottom row. Now, our results for the t-test, we are taking now from the bottom row. So if you felt that part of the leave-in, when you come to here, when you come to the t-test here, you are going to do a guesswork. And sometimes your guesswork can work because these two results can be the same. But when calculating the effect size, your guesswork is not going to work. Definitely it's not going to work when calculating the effect size. So you need to know correct figures to pick, right? You need to know correct figures to pick. So now, when moving to the step 2 test for equality of means, right? The next step is test for equality of means, where we are now going to check whether there's a difference between the current salary for the males and the females. So we are saying there are two rows: equal variance assumed and equal variance not assumed. So we will look at the equal variance not assumed row, right? As established from the what? From the result of the leave-in test, step 1, right? So in order to test if there's a difference between the current salary for males and females, we need to identify the null hypothesis and the alternative hypothesis, right? H0, there's no difference between the groups. H1, there's difference between the groups, right? So you go back to your results, right? Then this is the p-value which you are going to take, the bottom one. So what are we going to do? Are we going to reject or fail to reject? Yeah.
Yeah, we reject because it's less than 0.01.
Okay.
There's a difference. You know, there's no difference. There's a difference.
So what are we concluding to say? So after rejecting the null hypothesis, what are we concluding?
There's difference.
There's a difference. There's a difference.
Yes.
There is statistically significant difference. Okay. Between the salary of males and females, right? Okay, fine.
But let's say the variance is equal in terms of the move.
You look at the top row. Okay, so after establishing that there's a statistically significant difference, the next thing which you're gonna do is to check the group statistics table to see the means for each group between males and females. So which means from your results, you go up here, group statistics table. So this is the mean salary for the males and this is the mean salary for the females. So you can see that on average, males are earning 16,576.71 cents. And on average, females are earning 10,412.77 cents. So yeah, there is difference of around 6,000 something, right? Between their salaries. Then when you are doing PhD or when you're writing a paper, it doesn't end there. When you're doing PhD or you're writing a paper, it doesn't end there. You need to calculate what we call the effect size. You need to calculate the effect size, which is the effect size is the magnitude of the difference. You need to calculate the magnitude of the difference. So it doesn't end there, right? So they are calculated here, the coils D, the edges correction, and the glass delta. There are effective size statistics which are calculated, but for you to use them, you need to have literature to compare them with, right? For you to use them, you need to have literature to compare them with. So myself, I don't have that literature. I've not yet found it. So I prefer to use the eta squared statistics because that's the one which I know and which I also have some statistics to compare it with. So so the formula for the eta squared is t squared over t squared plus bracket n1 plus n2 minus 2, right? That's the formula for eta squared. So that one, when you get it, you can safely compare it with the Cohen guidelines, right? 0.01 small, 0.06 moderate, and 0.14 large effect. So what you then do is you go to your results here. Can you see now that the importance of knowing the row to use? Now we are saying t squared, right? You can see that there's a top t and a bottom t, and those values are different. So if you don't know which row to pick from the Levin's test, you are going to pick a wrong t. On the p-value, you have 1, right? You want lot on the p-value because they are the same, the top and the bottom. But on the effect size, you're not going to win. But they are different. So you need to know which value to pick, right? So in this case, you have to pick the bottom one, right? So you can prove 11.688 squared, which means 11.688 times 11.688 divided by 11.688 squared, right? Plus, then in brackets, N1. Where do you get N1? Sample size for the first group, which is 258. N2, sample size for the second group, which is 216. right? Minus 2 degrees of freedom. Then you simplify. Yeah. So you can prove if that calculation written there is correct. Mm.
I get on you. I have two questions. First question is, we have been testing our hypothesis when we said the two conditions. We need a categorical variable in two groups. Is it at least two groups or there's
2 groups only.
2 groups?
Yeah, independent details, 2 groups only.
And then continuous, you need a continuous.
Yeah.
Hypothesis testing when we have categorical data, we don't have continuous data. Maybe I want to test if there's a significant difference between the level of awareness between males and females.
Your level of awareness has to be continuous.
But I measured level of awareness with a constant. It being a constant.
Then you change it into a composite variable. Then you construct, you need to convert it into a composite variable. Then it becomes continuous.
Yeah, composite.
Composite variable, then it becomes continuous. These rules, they stick, they won't change. They will remain there. You won't change these rules.
So you have a constant
The reason why we include constructs in any study, right, is because at the end of the day, constructs can be converted to composite variables, then they become continuous. That's the reason why we encourage constructs to be included in any question here.
That's the first thing. Change it into a constant variable.
Then you do your t-test.
Is it a long process?
It's not difficult.
Can you please?
Oh.
Just an example of how you change a construct. Remember, it's a linear scale with questions.
Yeah.
But how do I go about making this continuous?
You use transformation in SPSS.
Use transformation.
And you either use the mean or sum, depending on the kind of construct. Some you mean, some you sum. Then you convert.
That if your research is descriptive, you don't need an hypothesis test.
Yes.
Now, what about independent test? We need to carry that out for a descriptive research.
Come again with that question.
Since we don't need an hypothesis test for it,
Yes.
we need to carry out
Descriptive statistics and independent t-test is something different. Independent t-test is a family of inferential statistics. Yeah.
which you have to carry out for any research, whether descriptive or not.
Look, for you to do independent t-test, it depends whether you do have an objective which fits it. Remember, we are saying in statistics, you don't just do tests. You do tests which meets your objectives. Yes. So if you do have an objective which meets the t-test, then you do the t-test. If you don't have an objective which meets the t-test, why are you doing it?
It doesn't matter whether it's descriptive or not, based on the nature of the test.
Don't confuse inferential statistics and descriptive statistics. For every study, you have to do descriptive statistics. For every study, yes. Then from there, you develop from being a descriptive study to do anything to do with inferential.
I also said that for any study, you have to do inferential statistics.
For you to be able to generalize to the whole population. If you don't have inferential statistics, you can't generalize to the whole population. Can you please hear me correctly? Yeah. Yeah. Yes.
Yes. Click transform on the SPSS. Say I want to transform a certain constant. Just quickly. In summer. Please just go to the SPSS. I see that it's transformed.
In this case, we don't have that example.
Yes, I know.
Yeah.
But please tell me this.
After hours. Yeah. Okay. So I hope even online you have checked if this is correct. If this is correct or not. I think when I was answering some questions, have you checked that formula? Okay. So at the end of the day, we get 0.22, 22 decimal places. Then according to COE in 1988, we do have some proposed guidelines whereby if you find a value in a squared value close to 0.01, it means the magnitude of difference is small. If you get a value close to 0.66, it means the magnitude of difference is moderate. And if you get a value close to 0.14, it means the magnitude of difference is large. Ours is 0.22, means it is a very large effect, right? Means it is a very large effect. So that's what we have, right? So then you can end there. Then you can end there, yes? This one, 2. Yeah. 2 degrees of freedom, representing the 2 groups. Representing the 2 groups in our analysis. Yeah. Okay, so any questions on independent test? If you want to get a distinction, you can go all the way to do this. Yeah. Okay, ZS, you've got a question?
Yes, yeah, thanks, Prof. Maybe if you can just recite to us or to myself so that I understand it, the issue of the continuous variable, and then number 2, when we get to the independent test or the t-test, the null hypothesis as well as the alternative hypothesis. And
I'm not
the
getting your
variance.
question. I'm not getting
Yes,
your question.
I'm asking about the continuous variable.
Okay,
1.
Okay, please ask the continuous variable. What about the continuous variable?
I'm asking, how do we then see that this one is a continuous variable again?
Did you attend level 1?
Yes, I did.
If you attended level 1, did you create the variable view with me?
Yes.
So what did I say? What is a continuous variable? Is there someone who can help us in the chat or here? Remember I told you those days that take note of this technology because we're going to use it. What is a continuous variable? Because that's what he's asking. Can you please answer him? Okay, you are giving us examples of continuous variable. But how can we define a continuous variable? How can we define a continuous variable? We did these things in level 1. Yes.
Yeah, but we were focusing on ordinal and and the nominal one, I think.
No, I remember I gave you the definition of a continuous variable. If you are being taught by someone, right? If someone was presenting, then we could say, no, that person didn't present. Okay, Bongani, you have helped, but this is not what I said. I see this, but this is not what I said. I remember what I said. What did I say about a continuous variable? Okay, what did I say about a categorical variable? Yeah. Exactly. Categorical variables, we say they are generated from what? From nominal and ordinal variables, right? So what about continuous now? Interval and ratio, full stop. That's what we said. So the moment when you don't understand interval or ratio kind of variables, then you can't understand the continuous variable. Yes. Yeah. Are you answered?
Yes, Prof.
Okay, sharp.
Now, the last question I had was the null hypothesis and the alternative hypothesis.
What about them? Your question is not clear.
Yeah, there are definitions. We're saying it's null because and it's alternative because.
Remember, we said the null hypothesis is an hypothesis of what? Of no difference. Right?
Yes, yes.
Yes. Which means an alternative hypothesis is the opposite. Right?
When we say no difference, Prof, what do we mean?
Okay, can you please check the way we are formulating these hypotheses? Okay, if we say here the variances are equal, something which is equal, is there a difference between two things which are equal? Yeah? If we say two things are equal, is there a difference?
No, there's no difference.
Yes. Check this one. There's no difference between the groups. Is there a difference? So
No.
that's a null hypothesis. So that's why we are saying it's an hypothesis of no difference. Yes.
Yes, Prof.
Hmm.
I'm still stuck on the conditions.
Which conditions?
Between age groups and then understanding ranges, 18 to 25, and then you have like 5 ranges or 4 ranges of 80. Then you want to test the relationship between age groups and salary.
One way and over.
Sorry?
One way and over. One way and over.
Is it necessary to do a normal test before we?
Yes. But remember, I explained last time. I explained last time to say it depends also with your discipline, right? Normally in social sciences, because we deal in social sciences in commerce, because we deal with like symbols, so there's no need of doing a normality test. But if you are in medicine, chiropractic, they deal with smaller symbols, so you have to, because they deal with smaller symbols, right? It's very important for you guys to listen. And I explained when we were dealing with normalities, I explained this point. Yeah. So in social sciences, when commerce, you end up using the central limit theorem because we deal with like symbols. But in disciplines whereby you deal with small symbols, it's very important to do a normality test. Yeah. Okay, any question? Okay, okay, let's move on to the Mann-Whitney U test. The Mann-Whitney U test is a non-parametric test used to test difference between two independent groups on a continuous measure. So it is the opposite of independent t-test, Mann-Whitney U test. It is the opposite of independent t-test. It is the non-parametric measure. So okay, so before we do it, can you please save your work here? Can you please save these results? Can you please save these results? So you're gonna say independent, independent t test salary versus gender. So that could be your label for your results. Independent t test salary versus gender. Or maybe to be specific current salary. Maybe to be specific current salary. Then once you save your work, can you, okay, once you label, save your work and close, then you close the file. If you don't close, whatever we're going to do will go below. Are we there? Okay, then we close. After saving, then we close. Then let's run our Mann-Whitney U test, analyze non-parametric tests, Ligas dialogues to independent sample. So can you see? Analyze, you go down non-parametric test, you go to Ligas dialogues, then you go to independent sample. It's kind of a journey to get there. Can you get that? Okay, are we there? Then we click. Once you click, you can see that the platform which you have from the independent test is exactly the same with this, right? So you just put your sound now here. You put your gender as well. You define your groups, 0 and what? And 1. You continue, right? Then you click OK. Define groups. So you put 0 and 1, just like what you did in the independent test. Are we there? Then you make sure that under test type, man Whitney, you is what? Is ticked. Right? Then from there you go okay. Right? You go okay. So the nice part about man Whitney U test is you just look for the asymptote sig two-tailed. That's what you look for only. Right? There's no equality of variances, there's no, right? So that's the reason why they say the independent t-test itself is more robust than the non-parametric, which is man-Whitney. Because here you don't look at all those previous steps. You just go straight away, you look at asymptotic, and you reject your null hypothesis, right? And you get the same conclusion with what you got with the independent t-test. Then you still need to calculate the effect size. Here, you calculate it by using Ri is equal to Z over square root of what? Of N. Then you go to your results. This is your Z, 12.286. So you can see that our Z here is got a negative sign. But when you calculate, you negate the negative sign, right? So for this calculation, the negative sign in front of the Z value should be ignored. You negate it. Then you write it as it is. You do your calculations, you get this value. You compare with this Cohen 1988 guidelines. 0.1 small effect, 0.3 medium effect, 0.5 large effect. It is very important that you realize that the Cohen 1988 guidelines for the parametric and the non-parametric, they are what? They are different. So it's very important for you to take note of that. Right?
And so you can take you said normally test we do it because we want to check one parametric or non-parametric. What are parametric and non-parametric tests? And how do we do the normally test?
I think normally test we did when we were doing descriptive statistics. We passed through there. Yeah?
I saw a problem. That's what I'm confused. Because you have a study, how do you know what to tell them, tell you which,
check in your, check in your, let me show you. Let me show you descriptive statistics. Here, I think, no. This one. You see? It is in that document. Descriptive statistics. Yeah, but guys, you know, when you get home, it's very important to go over these documents which I'm sharing with you.
So those results, each test.
You do it, they come together, Shapiro, Wilk, and Kolmogorov. Then depending on your sample size, you use 8 of them. 50 and above, your sample size, you use Kolmogorov. Less than 50, use Shapiro, Wilk. Yes, yes, yes. So if it's normal, you go parametric. If it's not normal, you go non-parametric. However, I also explained just now to this guy to say it also depends on the disciplines. In social sciences and in commerce, they don't normally do normality tests, but they deal with like samples. So they tend to use the central limit theorem, right? Then in medicine and chiropractic or homeopathic, they deal with small samples. So it's a must to do normality tests, but they deal with small samples, right?
Is the normality lower? What do you look at?
So normality test is also part and parcel of hypothesis testing. You still need this to the null hypothesis, the variable being tested is normally distributed. Then H1, the variable being tested is not normally distributed. So you still need null and alternative hypothesis. It's very important that the workshop material which I give you, right? You go over it, you check the examples, you do it as well. But for me to come and stand here, I'll have to spend some hours and even days to prepare this workshop material. So now if you get it, you just save it onto your laptop, you don't apply it, then yeah. It's not easy to prepare workshop material. It's not. So when you're given this workshop material, please make use of it. Okay, so I was explaining here that this COIN 1988 guidelines, they differ whether parametric or non-parametric. So here we're still getting an answer which is above 0.56, which is the large effect. So which means we will get a very large effect, if we can say. So what we are getting in Mann-Whitney is exactly what we are getting in independent test. The results are collaborating, right? So yeah, I think for today we end here. For today we end here. Ara, you've got a question? Huh? Yeah. Hello, Mike. Yeah, I did.
Hello, sir. Can you
Yes.
hear me? Yes, thank you.
Yes.
I just wanted to ask, earlier you skipped over the section with the correlation matrix and the covariance matrix and stuff. And when I was doing econometrics back then in coursework, they wanted us to also do stationary testing and heteroscedasticity and things. And then my supervisor asked for those kinds of things in my write-up. Are we going to go over that here, or is this not in this course?
No, that is econometrics, my brother, which you're asking.
Okay. Okay.
And also, all those unit root tests whatsoever, you are testing them on secondary data.
Time series.
Yes, sir.
On time series data. Yeah, secondary time series data. We
Okay.
don't cover that here.
Okay. Okay.
Yeah.
No worries. Thank you, sir.
But you have to use your if-use for that.
Yes, yes, yes. I did use it.
You don't use
100%.
SPSS,
Thank
you
you.
use
Okay.
if-use.
Noted. Thank you, sir.
Okay, sharp.
So what I do, like we got to postponing and then together to come. Like one since
I think we're good. I think we're good.
But then what you but children and do it. Carabanas are much no come and then my session by what I'm to name free and what do that maybe that I'm done with whatever then go that my session as Sarah to just eat up that then do postpone but rather we want it to manage but no I say and
I don't know that my mind was in the
best. Guys, those who are online, can you just express that you can hear me? Kindly just show by gesture that, okay, thank you so much. And also for those who are here, I think we just have maybe to talk about this, but since yesterday I've been trying to, our facilitator feel like the level of preparation because it's not really, going in line with the effort that is putting in preparing for the sessions, and so on, given that he's also have a lot of other projects that is sleeping at the office to make time for us. This is like almost from 1 to 4 yesterday, we are even up to 5. So he has been talking about canceling. You saw my email that I sent yesterday where I said, guys, please attend because the continuation of this depends on your attendance and so on. But also it depends on the preparedness of you guys, in terms of things that you would have already covered. Look, if we have covered, I remember in the first session you talked about issues of those are when he was talking about continuous variables and so on and so on, and all other issues that are in the document that he was reading out. And we also have, remember that first document that I shared there. So if you like maybe the level of preparedness, the time that he is investing in him, not really paying out as well for him, because he also has to be motivated, and it's us who can motivate him. So I'm trying to talk to him, say, because I don't think that, like, with the commitment that we have all put into this and where we are today, then we say no, we could not continue the session. Is going back to office and we need to the session. So I don't know, guys, what is it that maybe we can also say to him from
can please speak with Prof. For me, the training has been worked well, but I have a lot of things to assimilate a little time. So my plan is, after the training, I'm going to put the whole thing together, sit with them and take them bit by bit at my own pace. The whole thing for me is totally like a different part from my regular discipline. So it's not an everyday thing for me. So most of the things are so new for me. I need to sit down and redigest them before I can really put things together and operate with it. So it's like I'm still cutting and pasting and putting different things together to make a whole thing out of it. So I will apologize with Prof. I know it's very, very motivating, really, to not to move at your pace, and I can see your passion. But for me, that's my own side of the view. After the whole thing, I just to go and sit down with it, and I do a lot to be here every day. I don't stay around school. So if I'm not serious about this, I won't be investing that much of time and resources to come for this training. I spend a lot every day. Normally, I don't come to school every day. For me to take a whole week is a whole lot for me. So I know the value the training is bringing for me, but it will take me time to go and sit down and put the whole thing together. So it's not like I am not serious, but that's just my own point of view. So I apologize to Prof for the disappointment. So sorry.
Okay, so which means there's no need of sharing more because more of you are behind.
No.
So whatever we have done so far.
What are you trying to say?
Look, I hear your point. So hence, to add on to.
Still okay. Because we need to sit down. It's like we got 70% of 100.
Yeah, but I was also, even myself, I wanted to, before I started, I even told him that I'm going to be part of, I meet myself and do quantitative research. But I use SPSS, I use IFUs, I use data with sort of secondary data. So I've never done surveys, but because some of the things that he said, because of my knowledge of IFUs, and state, I know some econometric terms that he's using and so on. But I was also still to sit down as well and follow from the first session and follow the material, replicate what you'll be doing and so on and so on, So that's why we made it a hybrid, so that one day we can also sit with the resources. But for him, you also feel that we have to
Meet up with the
yes,
space.
also his effort. It's not good to repeat what we have.
Really, it's painful, really, but
Yeah, what
I'm
you
not trying
have
to plead with prof. It's not like we are not serious. Like Mr. Giving now, I've not done quantitative design before. This is my first time.
Yeah.
So most of these things are just new to me.
Okay.
So I need to sit down with them, pick them one by one. It might take me 2 months, it might take me 3 months if I can comprehend everything. So that's just the case. And if prof now stops, it still doesn't make it. I need the whole thing to make 100%.
Yes, and with everything that's been said, we apologize for keep on taking you back, but you will notice that we will ask you something you've said before because we want to link it with what you are saying now, so that the whole thing can make sense. It's because we've said normally you did speak about it before. Today we are really now bringing it into practice. So we're like, oh, Prof, what did you say? I said on to think about how it makes sense.
Okay, it's another perspective. Let's go online and hear what others have to say. I see there's essay there in RR. Can you maybe just give us your take on what we are discussing here? You can unmute yourself and talk.
So I'll just go. I will go first because I think you haven't allowed SA to give permissions to unmute yet. But for myself, sir, I'm saying I want to second what the colleagues are saying. I appreciate the effort and stuff. And the same thing, like this concept is new for me. So it's taking some time to understand the things. And also, like, we only get the material maybe like an hour or two before the class. So it takes time. I must download it, then I must unpack it, and I read it once, but I'm not understanding until I get to the class. And then, yeah, until we have
this one.
The focus was not on the material for today, but he's talking about material that was presented in level 1. You know, like for some of the questions were emanating from material of session 1 for level 1, where we did questionnaire design.
Yeah, but even I'm following, sir, but even for that, like, I only have maybe now one example. So the rest I have to just Google and say, okay, I must just try to refresh things to get other examples or something. So it's taking me some time on my own even to try and understand what is like appropriate or inappropriate to gain that deeper understanding. It's just taking time because this workshop has only been over a short period, but I'm not sure if the other colleagues will empathize with that or feel the same. Or if that's making sense.
Yes, we understand you, but his point is that it seems like we are also not referring to the resources that would have been shared with us, just maybe going through a little bit, or the notes that sometimes encourage us to say maybe right about this. Because I remember when he was talking about those issues of continuous variables and so on, you were saying write it down, make some notes. So it seems like also we are not that is the way that he is feeling, of which we also have to accommodate that as the facilitator as well. He has to be.
No, I understand. From my side, sir, I've been taking notes. I don't know about the rest, but I'll stop saying.
All right. Well, I'm also pleading with him, because I also, even for myself, for us to just leave it hanging as well. It's also not really even good for our records, because everything that we do post it on our platforms. Then it also doesn't really. So I'm also pleading with him to say that, but I also wanted to talk to you guys that also as well. Maybe we can, if we can have sort of a rejuvenated or a renewed perspective into what we are doing. I only invited you guys. I didn't even open for anyone else. Even if you check on our platform, when the flyer that went out for those who have received it, you can see there's no link or anything. It's actually closed and said open to only those by invitation. So which means I just wanted to see you through, and this is a comprehensive training package. I don't think he has ever done that for us as well. Because if I go in the past, it's just about 3 sessions or so. These sessions were 3. Then we expanded them to 8. So that he wanted us to, with him, because I went to him, have a meeting with him. He showed us that, okay, this is what needs to be done. For it to be comprehensive, we have to start from here. Then we split it and add another level. That's why we started level 1, then we went into level 2. So I'm also just splitting with you guys. Even the attendance itself, it also means a lot for him as well. Look, the time that he takes preparing these resources for us, and even just sharing the resources with us. Other people, it's difficult for them to just share something with, we've asked for many facilitators for us. When we ask them to say, give us your slide, they won't respond to you because they don't want to share the possibility material with other people. So we should be sort of grateful and be glad that at least he is taking his time out of his busy schedule with many projects that are lying behind, but he's taking time to come and offer this. He's the only one that we have. We wanted to do Stata. We couldn't do it because no one wants to do Stata for free. In our unit, we don't have money to hire someone from outside until we have budgeted for that. Then maybe we can look for someone external to say, come and do this. But he's the one who helps us always with SPSS and very knowledgeable on SPSS because that's what he do almost on a daily basis. So yeah, so maybe
just apologize to Prof. It's not. I think it's painful, but it's not what Prof is at all. That we are not serious. Honestly, I spend a lot of time every day from this period. I don't come to school.
All right.
Just once or twice a week.
No, we have heard you.
So please, that's not it at all, Prof. It's not at all.
So Doc, it's upon you. If you are announcing that this is the end of it, then we can announce that this is the end. But I'm just hoping that you see it the other way.
Maybe let's find another time during the.
No, so I think if you cancel, you'll have lots of us coming to ask you questions for personal meetings, and you'll have to teach us one by one again.
No, that's the truth.
So I feel like we are committed. Like, sir, we're coming here for hours a day, sir. Yeah.
That's not the truth.
Yeah, we're here for hours a day, sir.
I'm supposed to be in another
we have
meeting.
other things to do. Yeah.
I think you saw another meeting coming and I'm ignoring. You see, and I still have to attend. I'm a very busy person, guys. That's what you must do.
You understand? But please just finish this session, please. Please. Otherwise, you don't have.
Look, surely today, after more than a week, you're asking me what is the continuous variable. Guys, no. No. I'm hate. I don't want to lie to. I don't want to lie to you. At this point, asking me what is the continuous variable. More than a week, I'm hate. I don't want to lie to you.
That's what
The first letter. The parking must have right hand.
No.
Okay, ladies and gentlemen, for today, we are ending here. Okay, Dr. Gabriel will communicate with you whether we are continuing or not. Thank you so much. Yeah. Yeah.
Results were coming with something for
the matrix. Or let's go for the matrix. Yeah.
this other measurement of SPSS. They talk about creating matrix. Is it the same thing? Or
if you do the, remember yesterday when we were selecting on the extraction method, remember there was principal component analysis. Then there's somewhere where I said principal axis factoring.
yes.
Those two, they will bring a little bit different results. The name of the results will give you that one, yes, that method, yes. Then whilst the PCA and the Varimax give you rotated component matrix, then the principal axis factoring and the direct oblem We'll give you, it should be the pattern summary matrix on there. It's the same thing, yeah, 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 yeah. Okay, thank you.
You mentioned that you can publish using data. That was quite a revelation to me.
Yes, we publish data, yes.
Is there a paper that you have written just to?
Yes, I do have.
Can I send you an email and request you to send me an example?
So
that I can.
Okay, let me.
Trying to publish some of the things I've done.